Hi everyone, welcome back to the second casual series in Leetcode. So for today we're doing maximum number of words found in sentences. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. So what this means is there are spaces separating each word in a sentence. And we're given an array of strings sentences where each sentence represents a single sentence. So each item in these sentences is a single sentence. So this is a single sentence. And we have to return the maximum number of words that appear in each of these sentences inside this list. So for example, in the first test case, we have this list over here, and the first item is a sentence. In this case, there's 1, 2, 3, 4, and 5 words. So Alice and Bob love Leetcode. That's 5 words. The second sentence is I think so too. That's 4 words. And this is great. Thanks very much. That's 6 words. And in this case, across all 3 sentences, the third sentence is the longest, that has 6 words. So we return 6. For the second example, we have please wait as the first sentence, giving us 2 words. Continue to fight. That's 3 words. And continue to win, that's 3 words as well. In this case, there are 2 sentences that have the longest number of words, most number of words. So 3 words right here. So let's look at the constraints. The number of sentences given to us ranges from 1 to 100, very forgiving. And each sentence in this list ranges from 1 character to 100 characters, very forgiving. And each sentence consists of only lowercase English letters and spaces only, very forgiving. And sentences does not have leading or trailing spaces. So there's no need for us to strip the sentence before we count the number of words. So dot strip on a single string will clean up all new line characters and empty spaces on the left and right side of the string. There's no need for us to do that because we do not have leading or trailing spaces. All the words in sentences are separated by a single space. Very good. We can use a space as a delimiter to cut the sentences into multiple words. So with that, let's get started. A very simple approach we can use is to keep track of an integer variable that represents the most number of words we found thus far. And what we can do is we can use a for loop to iterate through all sentences in this input. And for each of these sentences, we can split it by an empty space to give us a list of words. And we can just get the count of words by checking the length of this word. And we will just set the most words found thus far to be the max of most words found thus far and the current number of words in this sentence. So that's a lot of explanation. So let's get into it. So the first thing we will do is define most words found. This is an integer, and this will keep track of the most number of words in a sentence thus far. So we can iterate through the sentence next for sentence in sentences. And for each of these sentences, that is a long sentence. So let's split that to list of words. This will be a list of a list of string. And this would be sentence dot split by a delimiter like this. So to our audience that are new to this function, split is a default standard Python function that is part of strings. So if you call dot split on strings, then you can specify the first parameter to be a delimiter. So if you wish to split a string based on commas, then you will do this. You would pass in a comma instead. And this will use this comma to split the string. So for example, if you have let's say you have a string called title, let's say title and ID. If you do dot split on this by an empty comma like this, this will give you a list containing title and ID. So notice that this this list of strings that you get back will not contain the delimiter that you specified. And in this case, the delimiter is comma. So in this case, let's say you have Alice and Bob love Leetcode, and you call dot split on it with an empty string, then this will give you back a list of size 5, Alice and Bob love Leetcode. So this is what you get back. So if you specify this, then list of words will be equal to this. So I hope this is clear. And what you can do is you can get back the length, just get back number of words. This will be equal to integer of length list of words. So because our list of words contain 5 words, this will give us back 5. And once we're done, we can just set most number of words to be equals to the max of itself and number of words. So max is a function that takes in as many arguments as you like. So if you pass in 3 to 1, this will give you back 3. So in this case, let's say most number of words is currently 0, right? And we pass in number of words equals to 5. In this case, we will set most number of words to be equals to this, to be equals to 5. And we will repeat this for all our sentences, and by the end of this for loop, you will be able to return back most number of words, and that should correspond with the most number of words you have in this list of sentences over here. So now that we have came up with this algorithm, let's quickly trace this out with a couple of test cases to be sure that we got this right. So let's say we have sentences equals to this. Okay, let's set this, so this is currently 0. And let's say sentence is currently this first sentence over here. And list of words will be equal to sentence dot split. This will give us back list of words equals to Alice and Bob love Leetcode. Number of words will be equals to 5 because the list contains 5 words. I hope this is clear for tracing. And most number of words in this case will be set to the max of most number of words and number of words. So this would set this to 5. So we are done with the first iteration. Let's move on to the second iteration. I think so too. So I think so too. I think so too. Okay. And in this case, this will give us number of words equals to 4. And max of 5 and 4, that will still give us back 5. So most number of words will still remain at 5. Now let's go through the third iteration. Sentence will be equals to, this is great, thanks very much. This is great. Thanks very much. So that is a list of words containing 6 words this time. So let's set this to number of words equals to 6. Most number of words will be equals to max of 5, 6. So most number of words will be set to 6. And we will terminate this for loop and we will get back 6. So is the answer 6? Yes, it is. So this is the answer. Let's run this against some sample test cases. Passes. Let's submit this. And okay, we passed it. Not fantastic. That's 25% top. We are only faster than 25% of all number of all submissions. But this is pretty decent. Yep, this is pretty decent. That's not too bad. Okay, so the time complexity in this case will be if n is the number of sentences and s is the number of characters in each sentence, the time complexity in this case would be O(n) because we iterate through all sentences inside this list, and inside this sentence we have to split the whole sentence by this delimiter. Under the hood, this sentence would have to iterate through the whole sentence to split it by this delimiter. So it takes some time. So in this case, this would be ONM, because in each iteration you will have this split. In this case will be OM. So this is ON. Number of words would be length of list of words. So in this case, the length, calling length on this string would take some time complexity as well. But assuming that if the list has an efficient implementation of length, and this is O1, then this is not too bad. And most number of words in this case is a single operation, so this is O1. So this is fine. So in summary, time complexity is O and M. Is there a better way to do this? You can also count the number of spaces inside this sentence to figure out the number of words. So let's say if you have, this is great, thanks very much. If we count the number of spaces, we see that there's 1, 2, 3, 4, 5 spaces for 6 words. So we can also choose to count the number of spaces as well. So let's quickly try this alternative approach. This will still give us back a time complexity of OM, because we have to go through all characters in sentence to count the number of spaces, but that would save you the need to do length on this, and that will also save you the space complexity of these words over here. Let's quickly go through the space complexity for this existing implementation. In this case, this would be OM, because you are keeping a copy of the split sentence over here. So you are taking up more space over here because you are declaring an additional list of words on line 19 for each iteration. Yes, you overwrite that during every iteration, but you will still be using up to OM space. If we didn't overwrite it, it would be ONM. But because we overwrite it on line 19, it's at least OM, where M is the longest sentence in this case. But since M can only be up to 100, so space complexity isn't too great, so that's fine. Okay, but if we want to make this O1, we can choose not to split it, and instead we'll just count the number of words. So number of words in this case will be equals to number of spaces plus 1, and we can declare number of spaces to be equals to 0, and we can iterate through for character in sentence. If character is equals to empty space, then we will just increment number of spaces. Yeah, so this is a way to count the number of spaces. So number of words will just be number of spaces plus 1, and that will give you back the answer over here. Let's run this alternative approach against some test cases. Let's submit this. Okay, the amount of memory used is actually didn't really change so much. I guess that's because the sentences is only up to 100 characters, so that's really not much use of space, so that's not too bad. In this case, we are lucky that the runtime improved. Yeah, you can see that if I run it twice, you can see that the runtime is more than the first runtime. I guess this depends on the Leetcode's cloud service and whether if we were running this code at the right time when the servers were not overloaded. But anyway, by counting the number of spaces, we cut down the space complexity over here, so that's not too bad. By the way, in a technical interview, if you have time, you can also abstract this logic to get the number of spaces into a separate function over here. So let's call this sentence string return back integer. We can do this. We can copy our implementation here and return back number of spaces like this. Then we can just spaces equals to number of spaces, pass in the sentence, and just like this, you have abstracted out the logic of getting the number of spaces. This would probably improve readability to your technical interviewer, so you can choose to do this after you have came out with a good implementation. So what did I do here? Why did I make a mistake here? Oh, number of spaces, sentence equals to integer number of... Oh, there was a clash between my variable name on line 14 just now, which is why it crashed. So if I rename spaces to another, function and integer. Function on integer, sentence in sentences, number of words. Oh, yeah, that's... Oh, on line 27, I called it number of spaces instead. That's why. Okay, so looks great. Let's submit this. Okay, it's actually... Okay, so I was just surprised that the runtime went down. The runtime increased a little, but it's probably just because Leetcode servers were busy. But yeah, this is a pretty decent run through of this question. I hope this was useful. If you like this video, please give us a like and subscribe, and we will see you in the next video.